All right, so we are starting a new unit over operations with polynomials. So polynomials are those expressions that have multiple terms, and we're going to talk about how to add, subtract, multiply, and factor those. Before we can do that, we have to talk about and review some base skills with exponents. So exponent rules are something that you have been exposed to before. Last year you did them in integrated. So this should be a review for you, but if it's not, we're still going through them. You should be able to pick them up pretty fast. So today we're going to focus on product and power rule. So product rule means when you're multiplying powers, you add your exponents. So just a little bit of vocab here. Powers is the whole thing. Like if I have x squared, that's the whole thing. Exponents are just the numbers or whatever the exponent is in the top right corner. In this case, my exponent is 2. Power is the whole thing. Exponent is just our small number in the corner. So when we're multiplying powers, that means we have a multiplication in the middle. We would add our exponents. So here, 11 cubed times 11 squared is 11 to the 5th. And I could also double check this works by using expanded form. 11 cubed is 3 11s multiplied together. 11 squared is 2 more for a total of 5. So if you ever forget the rule, you can always expand out to figure out what it would be. It's just more time consuming than using the shortcut. So again, here's our shortcut. In just general algebraic terms, you can think of this as your formula. A to the n times a to the m means we're going to add that n and m together. Our base stays the same though. That's important. Here it's 11 for both. So I still have 11. It didn't magically change to be 121. Here I have A, and A. Your base stays the same. So some more examples here. I do have the same base of 8 and 8, so I'm still going to have an 8. 4 plus 3 is 7. My base is 3. So I guess also back to our vocabulary here. The whole thing's a power. This is an exponent. The x is your base. So these have the same base. 5 plus 3 would give us 8. Here my base is x. 5 plus 2 would give us 7. Okay? Now, sometimes we're going to have coefficients, so we need to take a look at some of those examples. Coefficients, the numbers in front of your variable, you're going to multiply together like you always have. So here, this 5 and 2, it's still 5 times 2. It is not plus because those are not exponents. So we will multiply powers, add exponents. So we're multiplying our coefficients like normal. That'll give us 10. My base of x stays the same, and then I do 3 plus 10 to get 13. Okay, then here I have 3 terms, but it's still the same thing. Negative 3 times 4 times negative 5 should give me 60. And then I have a base of a, and I'll add my exponents. 2 plus 6 plus 3 should give me 11. Okay, again, you have to have the same base. So in this case, I have my coefficients. Negative 2 and 9 will give me negative 18. Then I'm going to do my x's and my y's separate from each other because they're different bases. So here I have y to the first. If there's not an exponent, it is a 1. And I have y cubed. So I'll have my y, 1 plus 3 is 4. Then I can do my x's separately because they're like terms, and I'll do x, 3 plus 10 is 13, okay? So you have to have the same base when you're doing these exponent rules. It's just basically very similar to combining like terms. We can only combine y's with y's and x's with x's if we're going to use this product rule as a shortcut. If they're not the same variable, not the same base, you can't combine them in this way. Okay, so our other rule we're going to talk about today is power rule. So when you raise a power to a power, you're stacking those exponents on top of each other. You're going to multiply your exponents. So here, let's expand this out so I can show you how it works. So 2 to the 3rd power is 3 2's multiplied together. And then I need 4 groups of that. So then total I have 3, 6, 9, 12 twos. Now, you're not going to want to expand out every problem, especially as the exponents get larger. So the shortcut to get from 3 and 4 to 12 is to multiply. So if you have two exponents stacked on top of each other, you're raising a power to another power. You are multiplying n and m together. Also, sometimes we'll see an exponent on the outside and there's two terms in the middle. You'll have to distribute whenever you see that. So this would be a to the m, b to the m. All right, so some examples of this. Here I have x squared to the fourth power. So I'm going to multiply those exponents. 2 times 4 gives me 8. Similar here, I have x cubed to the sixth. 3 times 6 gives me 18. So of course we'll also have some problems with coefficients, and then those are a little bit trickier because you treat coefficients and powers differently. We also will have to distribute. So here x squared b, remember this b has an exponent of 1. So we will distribute x squared to the fourth power, 2 times 4 gives us 8. For our b, 1 times 4 gives us 4. Okay, so again here, this 2 has an exponent of 1. A lot of times it helps to put in those ones. So I'm going to have 2, 1 times 3 is 3. X squared to the third, 2 times 3 is 6. And I'm going to do one more step and take that 2 cubed. 2 times 2 times 2 is 8. Okay, I want 8 in my final answer. Okay, so that is how you do product rule and power rule. You do have a 5-question Delta Math assignment to work on today.